What up, calculus students? We got lesson 2, no calculator. No calculator. But we don't need a calculator. We're venturing into the world of what's called an accumulation function, where we are accumulating g starting at a starting point to a variable, to x, to what we choose it to be. If you want to find a value, you're replacing x with that value, and you plug that value in for x, not for t. So you want to accumulate g from 0 to 6. This is the graph of g. Now it's like, oh, this is the graph of g of x. Well, what we talked about in class is don't worry about the variables. It's almost better if you ignore it and just think about just accumulating g. Like this could be an x-axis, t-axis, it doesn't matter. And we realize that we can find the accumulation of g because we know an accumulation visually is an area only keeping track of things above the x-axis as being a positive accumulation or a positive area, but below the x-axis would be a negative area. So we're starting at 0, we're going to 6. I need to figure out what's going on here. I could probably find all of the regions. This is a base of 1. This is a height of 4. So this area is 2. Cool. I can split this up into two triangles if I want to say this is -2, and then this is a triangle base of 1, 2, 3, 4, height of 1, 2, 3, 4. So this is going to be 8. Cool. Don't waste your time counting up boxes, please. Use area formulas of triangles and stuff like that. You could have also said this is a base of 5 and a height of 4 to get 10. And making sure you know that that's negative. So 0 to 6, I have this +2 and I have this -10. So I get -8. What did we also talk about is what happens when we go backwards? Well, it kind of makes sense from last unit, only we have to really pay attention that I'm going from 0 to -4. Maybe put like a little star saying like, this is where I start. And we realized from last unit that if you want to go backwards, you have to like subtract what you would get when you went forwards, or the area from 0 to -4, and I'm immediately going to flip it to be the opposite of the area from -4 to 0. I would recommend you do this, is like immediately say, well, let's go from -4 to 0. Let's just add all of the areas up like they are positive. But then when I'm going to write down my answer, I realize that it's going to be negative. So this is a base of 2, a height of 6. So this is 6. I'm going to split this into a rectangle that's a 2 by 4, and this is a 2 by 2. So I get that this is 16, but I will make it a -16. And then what we realize is that what we are looking at, this g, is actually equivalent to the derivative of f. And how did we first see that? We saw, okay, well, like f of -4 was -16. We can see that at 1, we have this 0. I'm going to find f of 1. We'll have to do that later. And f of 1 will just be this 2. And then we found f of 6, and we found f of 6 is -8. We realize, okay, f is increasing. It's increasing by 18, and then it's decreasing by 10. We realize that we are accumulating f's derivative. F's derivative is g. We realize that like this amount, 10, 6 to 18, tells us how much we're increasing. We realize that this graph of g is the graph of f prime. Cool. And we see f prime is positive until 1 and negative until that. And we'll use that to find max and mins and stuff like that. Which means f prime of 4 is the same as g of 4. Many people make mistakes if they actually don't learn this stuff, is they think that f prime is equal to the accumulation of g prime. And I'm actually thinking that that's correct, because we're going to talk about the accumulation of G prime. G prime is -4 over 2. And then, so that's -8, and then +2, -6. Is G of 4 -6? No, G of 4 is -2. So not the same. Yeah, cool. We'll talk about accumulating the derivative of G later. Which means the second derivative of f double prime would equal G prime. Now, don't memorize this stuff because like I'm gonna change it up on you later. You just have to start with what you know, that G is the derivative of f. Turns out f is the same as the antiderivative of G, which means like regular G is equal to f's derivative. If we wanted to go there, we could, but it's usually confusing for students. G prime of 4 is the slope of G at 4. And the slope of G at 4 is 1. When is f concave up? Oh, look at that. We are back to the world of a second derivative. Tells us about the first derivative's direction, which tells us about the original function's concavity. Well, we realize that G going up or down will tell us about f's concavity because G equals f prime. We realize that G's slopes will tell us f double prime's values. So G's slopes being positive or negative, or G increasing or decreasing is what we want to know. I want to know when f is concave up. F is going to be concave up when G, which equals f prime, is positive. This is my justification. F is concave up from -4 to -2 and from 2 to 6. If you want to use x equals, we're back to the world of x's. That's something I'll have to bring back to class. That's like, it's not t's, though it is t's. It's just like, think of t's and x's as interchangeable. How about that? F is concave up from -4 to -2 and 2 to 6 because that is when G, which equals f prime, is increasing. You need to somewhere, when we're doing our free response, you need to somewhere have this down, that G equals f prime. Like this has to be written down. And then once you have that written down, you just say G is increasing. Or if you want to repeat it again, it's fine. What's the max value of f? Okay, well, I can see f goes up, then f goes down. Like, boom, I have the behavior of f because I know about f's derivative. So I'm going to say f has a max at x equals 1. Why? Because f prime, and if you want to say f prime equals G, is positive from -4 to 1, and then f prime, which equals G, is negative from 1 to 6. Boom. I like to stack this year, like stack it. We write down our sign analysis. Boom, we have our sign analysis written down. And we want to find the max value. So we need to find f of 1. F of 1 is the accumulation from 0 to 1 of G. And the accumulation from 0 to 1 of G is 2. Okay, so here's my max value. All right, now I get a little curveball thrown at you. H is the accumulation of the derivative of G. What is H of 4? H of 4 would be the accumulation from 0 to 4 of G's derivative. Now, there are two ways to do this. One way is easier, one way is harder. Let's do the easier way. Again, we just understand that when we accumulate a derivative, it will tell us how much the antiderivative or the original function changes. Like if I know what g of 4 is, g of 0, and I know what g of 4, like I can subtract these two numbers and I will get this accumulation. These three things work together. Everything is a derivative of something else. So like we could do that and we could say find g of 0, find g of 4, subtract them, boom, you'll get your answer. Harder will be to figure out what the derivatives are because these are straight lines. Sometimes you'll be able to do that, sometimes you won't. So let's do the easier way. Well, this is the graph of g. G of 0 is 4. It's the point. G of 0 is f prime of 0 is 4. G of 4 is negative 2. If I go from 4 to negative 2, my accumulation will be minus 6. Now, the other way to do this is to be like, okay, g's slopes are minus 4 from 0 to 2. Like this slope is negative 4. And g's slopes from 2 to 4, this slope here is 1. If I accumulate negative 4 from 0 to 2, you could think about accumulating negative 4 from 0 to 2. And if you accumulate 1 from 2 to 4, this is going to be an area of negative 8. This is going to be an area of 2. Add them together, you get that negative 6. This is from 0 to 2 and 2 to 4. So like I'm not going to do that anymore because it's harder. I want you to know that like you can use the values of the antiderivative to help you out. Cool. So h of 4 is negative 6. What would be h prime of 4? Well, just talking about the derivative of the accumulation function. It's not g double prime. That's not what it is. Instead, it's just h prime will equal g prime. And that's weird, but like that's what it is, that the slopes of the graph of g will be the same as the slopes of the graph of f. So turns out like h is g, which is interesting. Yes, because like the antiderivative of g prime will be g. So it turns out h is g. So h of 4 is just g of 4, but it's not g of 4 because g of 4 is negative 2. Yeah, so like this is where it's like don't read too much into it. Oof. So h prime of 4 equals g prime of 4. The slope of g of 4 we found was 1. That means h double prime of 4 equals g double prime of 4. G double prime would be the slopes of the slopes. How can I figure that out? I have g. How can I look at the slopes of the slopes? Well, this is where we actually might have to go to our second derivative analysis and figure out, because it's asking for positive, negative, or 0. It's not asking me for the value. And what we have to realize is, oh, okay, if g is concave up, g double prime will be positive, which means h double prime will be positive. If g is concave down, g double prime is negative. Well, g at 4 has no concavity. Since there's no concavity, my answer is 0. Straight line. This is tough, but you'll practice. Hopefully not copying stuff down. I'm going to start going faster. All right, let's figure out that we're starting at negative 3. I don't know why I started you guys at those values. Did I start at negative? Like, I shouldn't have started at. I don't know why I'm starting you at these zeros. Yeah, if I could change it for next year, I will. Like, I could literally start this one at 0. It's just easier to start it at the x-axis. Anyways, that's my starting point, so we're paying attention to that. This is going to be an area of 6. 1, 2, 3, 1, 2, 3, 4. So this is a 12 divided by 2. This is 2, 4, so this is 4. This is 2, -4, so this is -4. And I'm going to think of it as a positive area. 2, 2, this is 2. Okay, so again, think of it as a positive area, but if you go backwards, you'll get the opposite of your answer. Okay, g of 4 will be -3 to 4 of f. -3 to 4 would go all the way here, so I have this 10, and then I have this -4, so I get this 6. G of -5, I'm going backwards from -3 to -5, which means I need to take the opposite of what I get when I go forwards. If I go forwards, I get 2. If I take the opposite of that, I get -2. The derivative of g will equal f. F of -1 is this value up here. Be careful, it looks like we have a slope of 1, 2, 3, 1, 2, 3, 4. Ooh, we have a slope of 4/3. So you're going to get, a lot of you are going to get this wrong. I'm going up 4/3 over 1, up 4/3 over 1. So I'm going up 8/3. So this answer is 8/3. Many of you are going to say the answer is 1, 2, 3, 3, but it's not 3. It's actually a little bit less than 3. You can kind of see that right there. It is to scale. So this is something kind of new to us. Maybe we saw it in the lesson where you are applying your slope to figure out the values. If you do 4 and you subtract 4/3, you'll get this 8/3 as well. G double prime will equal f prime. The slope of f at -1 is this 4/3. Double checking. G is increasing. Oh, G is decreasing. Let's see, let's just do our sign analysis. G's derivative is f. So I flipped up the value, the letters for you, just so that you know it's not always going to be the same f and g. Like, we'll use different letters later. So the derivative of g is f. Probably should have been the first thing I write down. So f, which equals g prime, is positive until -3, but then positive again till 2, and then negative, which means g is going to increase, then increase, then decrease. G will be decreasing from 2 to 4. My justification, that is when g prime, which equals f, is negative. Don't say it's decreasing, it's when it's negative. That's a little soft. You could have just said it's less than 0. Okay, g is decreasing when g prime is negative. G is concave down. G will be concave down when g prime is decreasing or g double prime is negative. I have that f is g prime. I'm looking at when the graph of f, which is g prime, is decreasing. Just -5 to -3. 0 to 4. Y, g prime, which equals f, is decreasing. Or you could say g double prime, which equals f prime, is negative, which is the same as the slopes of G prime, which equals F, are negative. Probably writing this underneath my face. Cool. Max value. Okay, boom. Max of G is at x equals 2. For sure, for sure, for sure. You could say one little thing caveat is like F prime, sorry, F which equals G prime is greater than or equal to 0. You could probably include that it's just greater than 0 from -5 to -3, and then from -3 to 2. But this includes kind of the fact that we have this like flattening out, this non-max or min. So it's good. If you want to go -5 to -3 and then -3 to 2, that's fine. You can say it's just negative from 2 to 4. There's your winner. Now we just have to find the value. Did I find it earlier? No. G of 2 is 4. Got to show the integral. It's not 4. It's 10. It's 2. We get G of 3 is 0. Increase 6. We get G of 0 is 6. Increase 10. We get G of 2 is 10. Cool. All right, back to the curveballs. P of 2 would be the accumulation of the derivative of f from -3 to 2. The easy way is to realize that the accumulation of f's derivative will tell you how much f increases. That will be f of -3 subtracted from f of 2. So I need to find these two values and subtract them to find my displacement of f. So I just need f of 2, and I need f of -3. F of 2 is 0, f of -3 is 0. Oh, cool, so 0. So this is going to be 0 minus 0, 0. Did it the hard way. You're accumulating the slope of 4/3 over 1, 2, 3. So 4/3 over 3 would be 4. So it's like easy enough to think like you're accumulating 4/3 over an interval of 3, and then you're accumulating -2 over the interval of 2. You get 4 minus 4, which is 0. So that works out really nice. P prime is the same as f prime. F prime of 2 is the slope of f. This is the graph of f. The slope of f at 2 is the slope -4 over 2, so -2. And the second derivative refers to the second derivative of f. And the second derivative of f at 2 is 0, because f has no concavity. Do now. Cool. P and Q. This is the graph of Q. Well, immediately I'm saying that's the same as the graph of P prime. Probably should have done that all along, but whatever. P of -4 would accumulate Q from -2 to -4. Okay, I'm starting at -2, so maybe I put a little star here, knowing that this is where I start. All of these triangles of area are going to be 4s. That's an 8. So let's say this is 8. Opposite of -4 to -2. Keep track. These are the ones people are getting wrong. The value is +4. And this should make sense if we know at -2, p of -2 is 0 because you accumulate from -2 to -2. We know that p prime is negative, which means p is decreasing. You have to decrease 4 to get to 0. You must be coming from +4 to decrease 4 to get to 0. Maybe that makes sense to you. Maybe you don't care and you're just trying to get the work done quickly. Whatever. When you start to care, it'll make sense. Okay, these cancel. 8 minus 4 is 4. P prime equals Q. Q of -2 is 0. P double prime equals Q prime. Q prime of -2 is the slope. I'm going up 4/2, so this is 2. Slope of Q. When does P have a point of inflection? So points of inflection of P, when P changes concavity, will be when P prime, which equals Q, changes direction, or when the slopes of P prime or the slopes of Q change signs. Excuse me. So I have the graph of Q, which is P prime. So I'm going to look at when P prime or Q changes direction. Changes from increasing to decreasing or decreasing to increasing. Let's just go with change of direction. So that's x equals 0, 2, 4, 8, and 10. This is P has a point of inflection when P prime, which equals Q, changes direction. What is the min value of P? All right, well, let's look at the derivative. Derivative is negative until -2. It's positive until 2. It's positive until 6. It's negative until 10. It's negative after that. So we have a bunch of these equal to 0 parts that we'll have to pay attention to. Okay, so P is going to decrease, then increase. So P has a min at either, this is an either situation, at either x equals -2. Okay, it's not going to be at 2. It's not going to be at 6. It's not going to be at 10. It could be at 12. Or x equals 12. Why? Now this is where we're going to be a little bit stickler about things. P prime, which equals Q, is negative from -4 to -2. Let's say less than or equal to 0. -4 to -2. And then 6 to 12. And then P prime is positive. We're literally just repeating the sign analysis from -2 to 6. That covers the entire interval. That justifies why these are your candidates. Now you just have to compare the candidates. P of -2 is 0. Just write down you're accumulating -2 to -2 of Q. The accumulation from -2 to -2 of Q is 0. And then P of 12 we found earlier, so we don't have to show the work again, is 4. So it turns out the minimum value is 0. It's the min location and value. So I decrease to get to 0, then I increase 8, I increase 8 more, I decrease 8, I decrease 4, I never get back to that 0 location. Cool. All right, back to this one where we understand that we have a different kind of idea. We want to accumulate the derivative, which you could do because these are straight lines. You can look at the slope times the interval, but it's easy enough to just find the change in the antiderivative. Just so you make sense of this. If you want to place q prime, if you want to know this value, well, you can look at q of -2, q of 4, see the change between these two, bam, 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 to bam, or this plus this equals that. It's like, that's the idea. Q of 4 is 4. Q of -2 is 0. So your answer is 4. W prime of 4 actually equals q prime of 4. The derivative of the integral will go away. You won't add a derivative on the inside. So if I do 4, oh, the derivative of q of 4 does not exist. Q has a sharp point. Good. I mean, I could have started you at 2 here, or 6. All right, next year. So always trying to make things better. Ah, gosh, I actually don't like that. I'm gonna make sure. It could be any number, it doesn't have to be a 0. If this was at 2, we'd still be able to do the problem. Just like n of 2 would be 0. To find the areas anyways, this is a half of a pi times 2 squared. So this is going to be 2 pi. It's underneath the x-axis, so it's negative. Split this into a 2 by 2. Split this into a 1 and a half. Okay. N of 0. Yeah, don't freeze on me. Desmo's open. I'm on best performance. All right. N of 0 would be the integral from 4 to 0 of m. Well, I need to say it's the opposite of 0 to 4. Make sure you pay attention. It's like start and end. Very important. Start, end is the opposite of left to right, start, end here. This is right to left, opposite of left to right. So it'd be positive 2 pi. You can think about this graph of m. M is the derivative of n. Take the derivative of both sides. M is n prime. So you can see m, which is n prime, is negative until 4, positive until 7. We can see that means n, which is the antiderivative of m, is decreasing than increasing. And we can see we decrease 2 pi, which means we must be coming from positive 2 pi so that we can decrease 2 pi to get to 0. I'll change the next homework and that'll be fine. I'm just thinking out. Then if I add 3.5, then boom. All right, that actually makes sense. All right, just 4 to 7. Just 4 to 7 is 3.5. N prime equals m. M of 2 is this value, -2. N double prime equals m prime. M prime is the slope of m. Slope of m here is 0. You can kind of see that's a horizontal tangent. N is increasing. Okay, N is increasing from 4 to 7. N is increasing from 4 to 7, as that is when M, which equals N prime, is positive. That's it. That's all you need for your justification. Was N concave down? N is concave down when N prime is going down, which is when M is going down, or when the slopes of N prime are negative, or when the slopes of M are negative. I'm just going to stick with this because I have the graph of M, which is N prime. So that is going to be from 0 to 2 and 6 to 7. Because that's when justification, here's my justification, M, which equals N prime, is decreasing. You can say the slopes of M are negative. Don't say the slopes of M are decreasing. That's wrong. Min value is at 4. We know it for a fact because N is decreasing than increasing because N prime is negative and positive. Min of N is at x equals 4 as N prime, which happens to be M, is negative from 0 to 4, and N prime, which equals M, is positive from 4 to 7. So that covers my entire interval. It shows me why this is my only candidate, and I find N of 4, which is 0. I found it earlier. Did I find it earlier? No, I have to show my work. 4 to 4. 0. Cool. L of 2 equals the accumulation of M prime from 4 to 2. Yeah, throw a real curveball at you here. Because this is the opposite of the accumulation from 2 to 4. Well, if I want to accumulate M prime, I can look at M's values from 2 and 4. This is like the no calculator of doing things. I'm glad I entered this in because it's nice and different. M of 2 is negative 2. M of 4 is 0. So if I go from negative 2 to 0, I know I've increased 2. And that means this is a positive 2, but I'm going to go opposite and I get negative 2. You probably need to show your work of like you're taking the opposite of 0 minus negative 2. I don't know if you need to show your work if you find these values. I think it's insinuated. If you get the right answer, you know what you're doing. You could also accumulate your derivative, but backwards. Oh man, you don't want to do that as the slopes are changing. So here's a situation where like you have to think about the non-calculator way of doing things. You have to know that accumulation of a derivative, anything's a derivative, is just the displacement of the original, whatever the original may be. Whether you go from f to big F or f prime to f, everything's a derivative of something else. Okay, L prime will equal M prime. So L prime of 2 is M prime of 2. This is M. Okay, it's still 0. It's still going to be the same. L and N are going to be kind of related. Oh, great question. L double prime is equal to M double prime of 2. Well, that's the graph of M. If M double prime is positive, M prime is increasing, M is concave up. This is the graph of M. This is the graph of M. What is the curvature of M from 0 to 4? M is concave up. Therefore, M double prime is positive. Hooray. We got two more. Great. Restarting. -1, again, I wish we started at -2. But we didn't. Change that up for next year. Change it up for next lesson and next year. So maybe put a star here. It does not have to be at the 0. I don't know why I put it there for every single one. I don't know what I was thinking when I made this one. Let's go ahead and find these areas here. I gotta split this up. Let's make sure we're thinking about them from left to right. 2 by 1, this is 2. This is a 2 by 2, which is a 2 as well. So this is 4. This is a 1 by 3, which stinks. This is a radius of 1, so this is a half of a pi times 1 squared, so this is pi over 2. But we're underneath the x-axis, so we'll go with a negative. If I split it into quarters, it'd be pi over 4. And this is a -1. Okay, g of 1 will be the integral from -1 to 1 of f. So I want to accumulate f from -1 to 1, no big deal. It's not backwards, it's left to right. G of -4 is going to be the accumulation from -1 to -4. Heads up, we're going backwards. I want to take the opposite of -4 to -1. So from -4 to -1, I have this for 5.5. So I'm going to have the opposite of 5.5. G prime of 2 is the slope. It's the same as f of 2. What is f of 2? What is this value? Well, you can see you go over 2 down 1, so down 1 over 2. Down 1 over 2 is equivalent to down a half over 1. Just divide the top and bottom by 2. So I go down a half, it's going to be -1/2. Again, since this is the graph of f is equivalent to the derivative of g. G double prime equals f prime. So f prime of 2 is the slope of f of 2, which is also -1/2. But this is the slope of f. Cool. This is the slope of f at 2. This is the y value of f at 2. Just so happens they are the same thing. When does g have a point of inflection? Okay, g will change concavity when g prime changes direction, when g double prime changes sign. I have f is g prime. I'm looking for when f, which equals g prime, changes direction. So it's going to be x equals -2, x equals 0, and x equals 1. Do I care that they're sharp points? No, I don't, because that is when my justification, that's when f, which equals g prime, changes direction. I'm not sure if they'll accept that. Increasing to decreasing, or vice versa. Min value. All right, let's actually look at the sign analysis. Okay, g prime, which is f, will tell us about g. We see g prime is positive until -1. It is negative until 1. It is negative after that. That means g increases, decreases, decreases. The min is either at -4 or at 3. Why? Because g prime, which equals f, is positive from -4 to -1, and g prime, which equals f, is less than or equal to 0 from -1 to 3. Now I just need the two values, g of -4. I did not, oh, I did find, it's -5.5. G of 3 is the accumulation from -1 to 3 of f. I have to show your work here because I haven't done it yet. And from -1 to 3, I do minus pi over 2 minus 1. Ooh, which one is bigger? This is close to 1.5 minus 1, which is minus like, how do I know what this is? Like, you can always replace pi with 3 as a good approximation. So if I do 3 divided by 2 minus 1, that's like negative 1.5 minus 1, which is negative 2.5. This is the winner. Cool. Good one to have an endpoint on. What is the max value of h, which equals the accumulation of f prime? Justify your answer. Okay, I need to look at h prime. Now, h prime is f prime. Slopes of f. Okay, so let's look at the slopes of f. It's a great question. Great question. Slopes of f are positive until negative 2. They are negative until 0. Like, yes, they kind of change directions at negative 1, but they're still negative until 0. They're positive until 1. And then they're negative. So that means h must increase, decrease, increase, decrease. All right, so the max h is at either x equals negative 2 or x equals 1. Okay, so I go up, down, up, down. So those are my only candidates. And I do have to say h prime, which equals f prime, is positive from negative 4 to negative 2 and from 0 to 1. And h prime, which equals f prime, is negative from negative 2 to 0 and from 1 to 3. Great. Now I need to compare my values of my candidates. H of negative 2 equals the accumulation from negative 1 to negative 2 of f prime, which is going to be the opposite of the accumulation from negative 2 to negative 1 of f prime. This might be easy enough to think about what is the slope of f from negative 2 to negative 1. The slope is down 1, 2, 3 over 1. So the slope here is negative 3. If I accumulate negative 3 over 1, I get negative 3. Take the opposite of it, get positive 3. Or you can think of what is f of negative 1. That's 0. What is f of negative 2? That was 3. So I went from 3 to 0. I decreased 3. I'm taking the opposite of it, which means I get 3. Oh, that's tricky. What's h of 1? Well, it would be the integral from negative 1 to 1 of f prime. It's probably easiest to do the displacement. F of 1 is 0. F of negative 1 is 0. So this is 0. So my max value is that. What a great question. I don't think I've ever done a question like that before. It works out nicely. So it's like I start at negative 1. I'm accumulating negative 3 y's per x over 1. And then I accumulate this derivative from negative 1 to 0. But from 0 to 1, it's going to counter, which means like I'm going to decrease, like accumulating that derivative and then accumulating the previous derivative. It means I decrease this amount, I increase this amount, and then I end up decreasing. Versus like if I came backwards, like I'm increasing by this many. I mean, is it the fact that it's just the y value? Is it the fact, like, why did I get a different value before? Oh, no. Negative 1 is 3, positive 3. Negative 2. That's the value, 3. I'm starting to trip. Is the value of L of 2 the same as the point? I'm just tripping here. So what tripped me off here? Is the value same as the point? 4. Yes. Yes. -6. No. Did I make a mistake here? I need to go back and look at this one. Oh, yeah, it's because of this starting being at 0, 4. I love how I use this one. This is a good problem. My first problem is the best one. I have this 4. So almost like I'm considering this as my 0, which is why if I go over to 4, X down 4. Okay. So it's not the same as the point. It's the same as the point when we shifted over things. So that's very interesting. Don't assume it's the point. How about that? I mean, I can show you why it's like actually like a vertical shift of things because of the starting point. It's almost like the starting point is where we're saying the value of G is 0. Right. So it's okay. I got it. Here, what we realize, and I was correct, but then I was wrong because I didn't think about it. What we realize is that you're taking the integral of the derivative. You are, if we wrote it out, realizing h is equal to g of t plus c, and how that's going to change from x to 0. So we actually get, and we did this, at h, oh, come on, I'm cooking here. We get that h is equal to g of x plus c minus g of 0 plus c. The c's will go away. H equals g of x minus g of 0. H is equal to g of x minus g of 0 is 4. H is the same, and this is very similar to what we're going to see next class, is the same as G shifted down 4 units. Why are we freezing? Not now, I'm doing great. So it turns out they are the same. Like H is the same as G, only H has like a different starting point, so it's shifting everything down. Why isn't that the case here? Well, because P will equal f at x minus f at -3. Well, f of -3 is 0. So it is the case that P and f are the same. Look at that. You want to find the max value of P? Oh, 0, 4, 4, -4, which I didn't ask for you. I didn't ask for. I did ask here. What about this situation? Well, like w of x will equal q of x minus q of negative 2. But q of negative 2 is 0. So this is why, oh gosh, maybe this is how I teach this. W and q are the same. Same here. I ask you for L of x. Well, you could like write this out by understanding that this is the same as m of x minus m of 4, but m of 4 is 0. So L and m are the same. And that shows up when we do this value. It's like, what's the max value? Well, you could say h of x. How about this? Or h of x equals, okay, again, like if I accumulate from -1 to x of f prime, I can look at f at -1 to f of x. Subtract these two values, right? This is the idea of the fundamental theorem of calculus, that everything's a derivative of something else. And if you like want to accumulate something, you look at its antiderivative. If you want to accumulate f prime, you look at f. You want to accumulate f, you look at big F. Okay, cool. So this is f of x minus f of -1. F of -1 is 0. So it turns out you could say h of x equals f of x, and then you could say the max f of x is -2, 3. That's the max, like literally you're looking at the function, which we've never done before because it's like so easy. But since we've almost looked at derivatives so much, this might be different. Really cool. Okay, so let's take that into account here, where it's going to be different. Good one, Dan. Great one to end on, because I see this 0.0 -1 is a great one to end on. All right. And I say the max value of G. Oh, it's great. It's great, great, great. So I'll show you two different ways to do it now, if we wanted to do. F of 2, integral from 0 to 2 of G. Let's find some areas. Okay, this is tricky because this is up 2 over 1. So this is going to be a half and 1. So this is going to be -1/4. This is going to be +1/4. Or I could say this is 1.5 and 1, 2, 3. So this is 3 times 3 halves divided by 2, which is 9 halves, so 9/4. Okay, it's not that bad. Now, what about this area? I hope we don't get freaked out by this. How do I find this area? Well, I have to find the rectangle and subtract the quarter circle. So this is a 1, 2, 3 by 1, 2, 3. This is a 9. And then this is a radius of 3. So this is going to be a quarter of a pi 3 squared, which is 9/4 pi. So this area here is 9 minus 9/4 pi, but in a big set of parentheses. If I accumulate from 0 to 2, I have a positive 9/4 and a negative 1/4, so I'm going to get 2. Immediately, I should be saying this is f prime, which equals g. F of 5. I'm going to have that 2, and then I'm going to add the 9 minus 9/4 pi, which is 11 minus 9/4 pi. Great. F prime equals g. At -1 is 0. F double prime equals g prime. The slope of g at 1 is this up 2 over 1, 2. This is the derivative. The derivative of f will tell me about f's behavior. It's positive until -1. It's negative until a half. And then it's positive the rest of the way. So f is going to increase, decrease, increase, which means I have x equals -1 or x equals 5 are the possible maxes. So F has a max at either x equals -1 or x equals 5, because f prime, which equals g, is positive from -2 to -1, and from 1/2 to 5, f prime, which equals g, is negative from -1 to -1/2 to positive 1/2. Great. Helps me not have to check all my candidates. I have f of -1. Did I find that? Nope. I do have f of 5, which I found, which was this tricky 11 minus 9/4 pi. F of -1 is going to be, this is a half, -1/2. So I'm going from 0, so that'll be positive 1/2. So I'm going to accumulate from 0 to -1, g, which is the same as the opposite from -1 to 0 of g. From -1 to 0 is -1/2, so this would be a positive 1/2. Which one's bigger? Well, that is tricky. Well, let's assume we're subtracting pi, which is around 3. You got 27/4. 4 goes into 27 almost 8 times. 7 times. 7 times. So it's almost like it's 11 minus 7. I will be subtracting more, so it's 11 minus something more than 7. Ooh. It's going to be close, but I'm pretty sure this is the max value. How can I check without a calculator is the question. I would do the actual arithmetic, that would take too long. I don't want to screw up this video, so I'm going to do it on my calculator. Yeah, it's like really, really close to 7. So we're going to get something close to 4. So that's 9 pi over 4. All right, so we're good. That's going to be bigger than 1/2. F has a point of inflection when concavity changes, which is when F's derivative direction changes. That's what G is equal to here. So that's going to be when G's direction changes, which is at 0 and 2. That's when F prime equals G changes direction. Oh man, I got class. Min value. All right, watch this. New to the video. P equals, well, if I want to accumulate G prime, I can just look at its antiderivative G over the course from 0 to x. All right, cool. So I'll subtract these two and I'll be able to get these. So I get that this is G of x minus G of 0. Well, G of 0 is -1. If I subtract -1, I will be adding everything, adding 1 to everything. Which means I can look at P, look at its max or its min, which is at -1. I'll add 1, I'll get the min of 0. Min of P is at P of 0, which equals -1. So the min of G, the min of G so the min P is at P of 0, which equals g of 0 plus 1. So p of 0 equals 0. Okay, let's say we did it a different way. We look at the slopes. The slopes are negative, then positive, and then negative. My candidates will be at -1 and 5. If I say, let's check p of -1, I will accumulate from 0 to -1 g prime, which will be the opposite of the accumulation from -1 to 0. Wait. Yeah, 0, 0, x equals 0, x equals 0. Okay, good. Boom, boom. This will be 0. We can already say that the accumulation of the derivative is 0. My derivative is negative, but going backwards, which means like I decrease to get to that value. And then I can look at p of 5, which is the accumulation from 0 to 5 of g prime, which is really just g of 5 minus g of 0. G of 5 minus g of 0 is going to be positive 1. So there's my minimum value. Oh, man, good stuff. Kind of a mind-opening experience for me because these are new problems that I haven't asked before. It showed up on the AP exam last year. All right, gotta go to class. Peace. What up?